Scientists just found oceans in space. Not a puddle, not a lake, whole worlds of water. Hidden seas, in the dark, perfect places for life. Number 1. A universe of hidden seas. Imagine a vast, dark ocean stretching for miles. It is a sea far away from Earth. It is not under a blue sky, but under a thick, frozen shell of ice. Scientists used to think this was just science fiction. A world with liquid water so far from the sun seemed impossible. But now we have strong evidence this isn't fiction. Scattered across our solar system, hidden beneath icy surfaces, vast oceans of liquid water likely exist. They are not just small pockets of slush. They could be global oceans, containing more water than all of Earth's seas combined. This is a monumental discovery. It transforms how we view the solar system. The habitable zone used to be our main guide. Now we know habitable environments can exist far beyond it, in the cold, dark depths of space. Number 2. Europa, the cracked and groaning moon. Europa, one of Jupiter's 4 largest moons, is a prime suspect in the search for hidden oceans. It is a world slightly smaller than Earth's moon, but its surface is unlike anything we have ever seen up close. It is a brilliant, bright sphere of water ice, crisscrossed by a bewildering network of long, dark streaks and cracks. These features, called lineae, look like massive fractures in the ice. Scientists believe they are caused by the immense gravitational pull of Jupiter, which stretches and squeezes Europa as it orbits. This constant flexing, known as tidal heating, could generate enough warmth deep inside the moon to keep a vast ocean of water in its liquid state. The first strong clues came from NASA's Galileo spacecraft, which orbited Jupiter in the 1990s. As Galileo flew past Europa, its magnetometer detected a strange disturbance. Jupiter has a powerful magnetic field, and as Europa moves through it, a secondary or induced magnetic field was detected around the moon. This is exactly what you would expect to happen if there were a layer of something electrically conductive beneath the ice. A global ocean of salty water would be a perfect conductor. The data from Galileo provided the most convincing evidence yet that Europa was hiding a massive saltwater ocean beneath its frozen exterior. Further observations have only strengthened this hypothesis. Hubble has detected faint water vapor plumes. Chaotic ice that shifts and refreezes looks like sea ice on Earth. Number 3. Enceladus, the little moon with a big secret. For a long time, Enceladus was just another small, icy moon of Saturn. Barely 500 kilometers across, no one expected it to be so geologically active. Everything changed when Cassini arrived at Saturn in 2004. During close flybys, Cassini made a breathtaking discovery. It saw enormous plumes erupting from long cracks near the South Pole. The jets shoot hundreds of kilometers, feeding Saturn's E-ring. Cassini didn't just see them, it flew through the plumes. Its instrument sampled the spray. The analysis was stunning. The plumes contained water vapor, ice crystals, salts, silica dust, complex organic molecules, the carbon-based building blocks of life. Silica forms where hot, mineral-rich water meets rock at high temperatures, a strong hint of hydrothermal vents on Enceladus's seafloor. The plumes require a liquid source beneath the ice. Radioactivity alone can't power these geysers. Enceladus is squeezed by Saturn. Tidal heating drives the ocean and the plumes. Cassini's gravity measurements confirmed a global subsurface ocean, estimated 30 to 40 kilometers deep. Enceladus has effectively sent us a free sample, a direct path to study ocean chemistry without drilling through kilometers of ice. Liquid water, a source of energy, tidal heating, and hydrothermal vents. Organic molecules. This tiny moon now tops the list of places to look for life beyond Earth. Number 4. Ganymede and Titan, giants with buried treasure. Europa, Enceladus, not the only ones. Ganymede, Jupiter's largest moon, larger than Mercury, is the only moon with its own magnetic field, driven by a liquid iron core. Hubble saw its auroras rock less than they should under Jupiter's pull, a crucial clue. A vast, salty ocean can create a secondary magnetic field that resists Jupiter and steadies the auroras. Models suggest an ocean sandwiched between ice layers, perhaps with more water than Earth, but likely not touching rock. If it's sealed off from rock, key chemistry for life is harder. Titan has a thick, nitrogen-rich atmosphere and lakes of liquid methane. Too cold for surface water, but data show its crust is decoupled, floating on a deep, very salty ocean, perhaps as salty as the Dead Sea. Unlike Europa or Enceladus, Titan's ocean is likely trapped between ice layers, not touching rock. But Titan's surface is rich in complex organics. Some may sink through cracks, delivering prebiotic chemicals to the ocean below. Ganymede and Titan show ocean worlds can form in different ways, expanding the number of places that might hide vast water reservoirs. Scientists have never seen these hidden oceans directly, so how can they be so sure they exist? The answer: clever, indirect methods, like cosmic detectives piecing together clues. A salty, liquid ocean moving through a planet's magnetic field will generate an induced magnetic field. Spacecraft magnetometers can detect that faint signal. Galileo did at Jupiter. On Europa, cracks, ridges, chaotic terrain suggest the icy crust floats on a liquid layer. It fractures, shifts, even subducts like plates. On Enceladus, plumes shoot water vapor and ice into space, a visible sign of a liquid reservoir below. Tracking spacecraft motion maps gravity, revealing interior layers, dense core, lighter ocean, lighter ice shell. Cassini showed Enceladus is less dense at the South Pole, matching a deep ocean under thinner ice. Too far from the sun, these moons are warmed from within. Detecting heat or active plumes tells us ice can melt and oceans can stay liquid. Our understanding would be non-existent without the robotic explorers we sent to the outer solar system. Voyager 1, Voyager 2, grand tours that gave our first close-ups of icy moons. They revealed Europa's strange, cracked surface and hinted at activity. Galileo studied Jupiter's moons in detail. Its magnetometer gave the first strong evidence for a subsurface ocean on Europa. It revealed Ganymede's intrinsic magnetic field and hinted at a buried ocean. From 2004 to 2017, Cassini found Enceladus's plumes and flew through them, confirming water, salts, organics. It pierced Titan's haze and found gravity clues for a subsurface ocean. Hubble added long-term eyes, spotting possible Europa plumes. Next, NASA's Europa Clipper and ESA's JUICE will probe these worlds in greater detail, confirming oceans and testing habitability. Future ideas: sample Europa's ice, capture pristine Enceladus plume grains for return, even melt through the ice to swim an alien ocean. The discovery is exciting for one main reason: water and life go together. On Earth, everywhere we find liquid water, we find life. Boiling hot springs, frozen Antarctic lakes, the crushing deep ocean. Water dissolves and moves nutrients, powering chemistry. Life as we know it needs three things: liquid water, essential elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, and a source of energy. These ocean worlds seem to have all three. We've detected organics in Enceladus's plumes. These elements are common, likely in rocky cores and sea floors. Tidal heating keeps oceans liquid and powers chemistry. If water touches rock, hydrothermal vents can feed life via chemosynthesis. These are not sunlit worlds, but deep, dark realms powered by internal heat and rock-water chemistry. Any life there is likely microbial, adapted to cold, pressure, darkness. Finding even simple life would prove life isn't a fluke. It emerges wherever conditions are right. It would change everything. Despite compelling evidence, we still have big gaps. How thick are the ice shells? Europa could be a few kilometers, or over 30. We barely know the chemistry. Are these oceans salty like Earth's seas, or more like fresh water? Which minerals? Chemistry controls habitability. We have strong hints of vents on Enceladus, reasons to suspect them on Europa, but no direct proof. If Ganymede's ocean is trapped between ice layers, it may be cut off from energy and minerals. Do these oceans harbor life? Even with water, energy, and chemicals, life may still not arise. The origin of life is a deep mystery. We need sophisticated instruments to detect biosignatures, subtle chemical and molecular signs unique to life. NASA's Europa Clipper, launched in 2024, is en route. ESA's JUICE will orbit Ganymede and fly by Europa and Callisto, mapping subsurface structure. Next steps: land on Europa's ice, scoop plume grains at Enceladus, even return samples to Earth. Ultimate goal: melt through the ice and explore an alien ocean directly. Keep watching the skies. The next great discovery may be in the dark, silent waters of a distant moon.